Good afternoon, everybody, and welcome to ARC's third quarter web window in 2019. My name is Mark, and I will be the moderator for today's session. ARC's web window is a webinar series that has started in 2015, covering current industry hot topics each quarter. In this web window, my colleague Valentine De Leo will discuss how asset management, asset information management, and asset performance management can fit together to create a single asset strategy in the context of digitalization. And now, without any further delay, I would like to pass over the word to my colleague Valentine. Valentine, can you hear us?
Yes, Mark, thank you so much. Can you hear me?
Yes.
Okay, that sounds good. Thank you very much. Hello, everyone. This is Valentine speaking. I'm a vice president at ARC based in Brussels. In this presentation, we will look at best and recent practices in asset performance management and discuss how they fit together with asset information management and portfolio management. So we have a few sections in this presentation. I'll start with a brief overview of the aspects that we discovered in digitalization, because they have an impact on asset performance management, modern asset performance management. Then we'll have a look at the different processes. We'll look into operations versus asset performance management, the governance of all of this, that is the optimization of the asset lifecycle, and look how asset information management is important for APM. We'll look into some challenges that we encounter and solutions, possible solutions that can be proposed to solve those challenges. We'll look into costs of poor asset information and performance management and the benefits that the solutions could bring. And then I'll go through two examples briefly and summarize the outcomes of good asset performance management. So you hopefully realize that this is a short webinar, so we can't go into detail, but we have a lot of writings on this, and we would be happy to provide you with more information. ARC is a global technology strategy consultancy. We work in the domains of industrial design and operations, infrastructure and cities. We cover a range of technologies from automation through instrumentation, industrial IT and IoT. And we typically deliver market size and trend reports, best practice reports, industrial benchmarking, technology strategy, blogs, speaking engagements, and so on. And at the bottom, you see a summary of a few of our industrial clients. So briefly on digital transformation, we noticed that there is a lot of talk about technology, and of course that's very important. However, we also started realizing that there was more to digital transformation than only technology. We figured out that nothing happens without strategy, that they impact business processes, that new business processes can add additional value, that ecosystems and relationships are very important, much more important than in the past, we believe. Of course, organization and skills remain an important topic, but we also figure that behavior of people and norms and culture in companies do impact implementation of digital transformation. Innovation is key. Innovation is faster and faster. Economic, environmental, and social sustainability gain importance and can be affected by digital transformation. Leadership and empowerment have an impact on behavior of people. And then there is risk management and compliance, which has always been an issue, but that can be definitely impacted through digital transformation. And then finally, there is the organizational rules or organizational fundamentals that do impact behavior of whole organizations. So this whole set of aspects impact digital transformation, and we'll touch upon a few of those in this presentation today. The others have been treated in presentations and articles. So again, don't hesitate to reach out. Asset management in the digitalized manufacturing world. We could represent the asset lifecycle as a sequence of activities. We start with planning, then we design and engineer, then we procure, construct, and qualify the installation. And the most important one is the operations and maintain phase, where the real value is obtained. That should pay back for the investment. And then ultimately there will be, or there could be, a retirement phase. And you see that there are some sub-activities in each of those. And in the operate maintain, we see optimization, monitoring, maintenance, modernization, and so on. But that picture, if we look closer at it, is a little bit more complex, because there are many entities in the ecosystem that participate in those activities. External service providers, equipment providers, engineering services, IT and OT system providers. So there are many people and organizations that collaborate with the operator in order to make that operations phase work properly. So the ecosystems are important, as I also said before. Now we have represented that cycle linearly, as you see here, in a slightly simplified way. Although it isn't completely linear, and we will see that in a minute. But before that, I would like to define asset performance management. To us, it is the set of practices intended to optimize the performance of physical assets in their operating ecosystem. Maybe we should extend physical assets to also virtual assets. In any case, that's an instantaneous view. So to do that, we use operations data, we use asset health data, life cycle data, together with software and digital models and analytics to optimize individual assets and asset systems in their operating environment. But it remains a relatively short-term view of optimization. And so we consider asset performance management, as you see in the little bar above the operate maintain arrow, as really related directly to operations and maintenance. And if we talk about the optimization of the full asset life cycle, then we speak about governance, or is also sometimes called portfolio and project performance management. It really optimizes all the performances of all the activities and processes, including projects, including operations, and so on. So the two fit together, and asset performance management really serves portfolio and project management. And the latter is really a circular or an iterative process. So we start with some planning, we start with a policy and a strategic plan, and we derive a short-term plan for that. And then the short-term plan, we do some prioritization and we look into resources and feasibility, and we implement some projects that will result in changes in processes and assets and systems. And when we have done that, we will monitor the result of that. We will evaluate that performance. We will include that in the next plan. We will update the strategy and make a next plan. So we keep improving, and we keep also incorporating changes from the environment, the economy, the society. So that governance or portfolio and project performance management interacts with the asset lifecycle. And what will happen is that we will see a need for a change in our asset. We need to modernize it, we need to update it, we need to extend it maybe. So in the middle of that operate maintain phase, we will have little phases with new projects where we again plan, engineer, procure, and construct. And there can be many of those, and there can be many at the same time as well. So again, the asset performance management serves this portfolio management or governance process that overlooks it over the full asset life cycle. And if we do that, if we do that governance and asset performance management, then in order to make good decisions, we need good information. And it seems very obvious. However, the reality is that not very many industries have that information accurate and up to date and ready to use. We start collecting that information during the planning, the engineering, and the construction. There's a lot of engineering design information first, and then information on equipment we purchase and the way we install it, and then we start operating, and we can continue to collect information. We can also collect information about the maintenance we have been doing. We can also document why we have been making those decisions. So our asset information management is really growing over time and is modifying itself over time. And it's interesting not only to have a good snapshot of today, but also be able to wind back the timeline and look into decisions we've been making in the past. We consider that we should be very broad in the asset categories that we use in providing the asset information. So we consider physical assets, human assets, virtual assets. You see a very broad range of information types, and we use those in the different processes that we mentioned. We use them in the projects, we use them in the asset performance management, and we use them in the governance. These tables can be found in publications that we have made earlier, so you can get back to that if you need to. And I'll insist on the importance of that asset information, the quality of that asset information, and the way it is being transferred through the organization and across organizations over the asset timeline. And if you look at the study that has been done by NIST a few years ago, you can see that there is almost 2% of the total capex cost that is usually lost by poor handover between the engineering, procurement, and construction company on the one hand to the owner operator. So the information doesn't really get completely transferred. And then keeping that asset information accurate is also very important, and usually there is some asset information erosion going on. And the lack of that information is really costly. And it is costly because we start making not quite right decisions about maintenance, about operations, and sometimes those decisions can work out dramatically, as we have seen in major accidents. So there is a real business case of having that asset information right, and then create a foundation, a good basis for the processes on top of those. Now, state-of-the-art solutions for that are cloud-based collaborative environments. Cloud-based, of course, makes it easy to collaborate. And of course, it needs some security measures to make sure that it is cyber secure and it protects the IP of the different parties. But if you have that in place, then the exchange is much more efficient, much more immediate, and so you get a better chance to have accurate information in your asset information repository. And we would suggest that would include 1D, 2D, and also 3D engineering information. It would include maintenance information. It could include operations historical information. It could include documentation of decisions you have been making. All those types of information can be there and can help us, informing us when we need to make new decisions. So accurate, up-to-date, and accessible. Those are the criteria for the quality of asset information. And then we complement that with analytics. First of all, to see if that asset information is accurate and complete, but also to evaluate the health of our assets and the performance of our assets. An example here is a photograph that has been made intelligent, and so if you click on one of the equipments, then the equipment gets highlighted, as you see in the slightly rosa cases. And if I click on that, then I get the information about that asset here on the right side. So there is a link between the context, which is here 3D model, and the engineering and maintenance information. And this context helps, of course, understanding that information and helps making decisions. So this is what we consider to be state of the art. And if you would also be able to go forth and back to historical process information, then you start feeling that this is efficient for people using it. So with these kind of tools, we can improve the information interoperability significantly, and we can gain back the losses that we just have been mentioning that were determined by the NIST study. We can further improve that by using a standard information structure or standard information model, which basically makes it easier for everyone in a global company to find information in standard places. And once we have that information in place, then we can start building digital twins or simulation models. And we can start with smaller equipment, and we can build systems and plant models. And those can be, let's say, informative, like a 3D model, or they could contain engineering information, but they can also be let's say predictive. We could run scenarios, we could look at the performance against the design, and so on. And if we do it really very well, then we could have snapshots of those digital twins at significant points on the timeline of that asset. And that could also help with regulatory requirements. And so we start understanding the behavior of that asset. We can explain it with all those tools. So how does industrial IoT support asset lifecycle information management and asset performance management? Well, we've seen cloud and software as a service solution just 2 slides ago. With that, we can have engineering companies looking over our shoulders and helping us troubleshooting, monitor equipment performance, giving us advice in how we should react on certain behavior. We could use analytics. We could add IoT sensors or use digital information from smart sensors to be more informed. We could add predictive and prescriptive analytics, and all of that will result in reducing latency in making decisions. Decisions that we make use time to make. We need to figure out where the data are. We need to analyze those data, and then we need to make a decision. And in former times, that would take longer than it takes today, because we get those data points much earlier. We automate part of the analysis, and so we can make those decisions more quickly. And more quickly often means the possibility to gain additional opportunities, to make money out of additional opportunities, or to avoid additional damage or cost. So speed is money, time is money, again, here too. So we improve the overall asset value and the production value. A few examples. This is coming from a white paper published by Intel a few years ago, and it shows very well how this can work. On the right bottom, the blue box is the production facility. It has a tester that tests the quality of the chips produced. And those testers also need maintenance, so they can make wrong decisions in some cases. So at some point they start downgrading good chips, and that's a lot of money lost. So with the gateway built into the PLCs, we can send that information to a cloud system where we do data analytics, And based on the data analytics, we can start predicting if that tester still works properly or if it needs maintenance. And in this particular case for Intel, that resulted in reduced non-genuine off-spec losses of 25% and a saving of 20% in maintenance costs. So that's really, really significant. There are other cases explained in this white paper, and you have the link to that white paper at the bottom of this page if you want to look that up. Another example that I would like to mention is an example from a local company not very far from here. But I really respect them because they are very structured in the way they do this. They are a maintenance service provider to a multitude of owner-operators on an industrial site. They use ISO 55000 as a framework. They determine the priorities for their assets, so they look at which assets create most of the cost or create most of the opportunity cost when they stand still, and those are the ones they give the most attention to, and there is where they use the most advanced technologies such as advanced process control or predictive analytics or simulation models. And there are actually only a few of those cases, and then there are of course intermediate cases where they do regular monitoring over time of the assets, usually one variable. And then there are assets which are not really important, so they spend much less time. So this is a very structured and rational way to build a maintenance strategy. They also apply some IoT sensors, and with this, they've been experimenting now since a few years, and not long ago they had 25 pilots running. And they can mention 3 cases publicly. The one is fan vibration monitoring, so you get vibration when the filter gets fouled. You can do heat exchanger fouling monitoring. This is a classical one. And you can predict failure of pump valves. And with all those cases, they mentioned they are capable to demonstrate they gain millions and millions of avoided costs. And in addition to that, they pay a lot of attention to the people, so they do motivation, they explain what they do, why is it important what they do. They use processes that are in line with their framework, and of course they apply the technology that I just mentioned. So this is a very structured way. We have written about this in an article, and you can also read about that a little bit more if you want to. So why does this all matter? Well, here is a benchmark, and this benchmark says that in world-class oil and gas producers, you find 95 to 98% of availability, which is very, very little downtime really for this industry. And the clue is that those world-class companies, they make the right decisions on savings. So rather than delaying maintenance, they delay some maintenance and not the critical maintenance. It ties back to what I said in the previous slide. They are very rigorous in executing their plans, and their processes. So they are very, very rigorous and systematic. And with all that, they improve the availability while they're reducing maintenance costs by 25 to 30%. And that's important. Now, if you work the opposite way, if you just start making savings, then you will immediately see that availability goes down, and after your availability goes down, you start fixing problems, and then the cost goes up. So it's actually the contrary of what you would like to do. And if we compare this with the ISO 55000 standard, it is really an operational excellence process. And you will find back all these different aspects that you saw on the previous slide. So these world-class companies, they actually must be using this kind of framework where they set a strategy, they make a plan, they invest exactly where they have decided to, They make sure they flawlessly execute what they did. They assess and improve. And that's the way they remain excellent. So all of this together should lead to increased productivity, increased reliability, maintenance cost decreases, shorter time to market or shorter time to operational readiness, improved service levels, so improved delivery, reduced cost of inventory, reduced environmental footprint, reduced compliance and regulatory cost, and finally, it also contributes to social sustainability. So that was the summary of the outcomes.
So this is all we have for today's webinar. Thank you, Valentine, for your presentation, and thank you all for joining our web window.